going to go over the numerical revision quiz 1, just in case I can't meet you guys tomorrow. Okay. Plus, it's also good for you to have it so you can watch it anytime you like. Right, so the first question then is changing our height into meters. So this person is 5 foot 7 inches. We're going to start by taking that 5, timesing it by 12 to get 60. Remember, and add on the 7, so 60 add 7. Altogether, this person is 67 inches tall. 1 inch is 2.54 centimetres, so we do 67 times 2.54. That gives us 170.18. That's in centimetres. We want a height in metres. So we're going to divide by 100, which gives me 1.7018. I want 1 decimal place, so 1 number after the point, 7, second one after that's a 0, so it doesn't round up, it stays as a 7. So 1.7 metres. The next one then, changing from 9 stone 7 pounds into kilograms. We start with a 9, it's 14 pounds in a stone, so we do 9 lots of 14. Which is 126. I was going to say that, I just wasn't 100% sure I was right. We've got an extra 7, let's add on that 7. 126 add 7 is 133 pounds altogether. Okay, there are 454 grams in a pound. So we're going to times. So you get 60,382. So there's 60,382 grams. I want a weight in kilograms. There are 1,000 grams in a kilogram. So I'm going to divide by 1,000. That gives me 60.382 to 1 decimal place. Here's my decimal point. We've got a 1 number, which is a 3. After that's an 8, so that's going to push that up to a 4. So we get 60.4 kilograms. Third part then, this is when I hope my memory's okay. Calculating the BMI, so 60.4 and 1.7. Write them down quick before I forget them. BMI is weight over height squared, so it's 60.4 divided by 1.7 squared, which is 60.4 divided by 1.7 squared. Oh dear, I seem to miss this decimal point. 1.7 squared, which is 20.8996, so 20.9. And we're interested in what category it is, between 20 and 25, so it's acceptable. Next question then is the wee bit that you maybe haven't seen before, okay? But it is just proportion. So I think you'll be fine with this. Okay? So a newspaper claimed there were 170 alcohol-related deaths per 100,000. If we have a population of 2,780,000, how many deaths would be expected due to alcohol? Okay. That means for every 100,000, there are 170 deaths. We want to know how many lots of 100,000 we've got. So I'm going to take our 2,780,000, divide by 100,000, and times that by 170. I've missed out a 0. That should be 278,000. So that'll be 4,726. I'll type that into the calculator properly so you can see it. Oh, no, that's come back too far. Get rid of that. Pressing the wrong button. Right, 278, 1, 2, 3, 4. There we go. Divided by 2, 3, 4, 5. The reason I knew that was wrong so quickly is because I've already been through this and recorded it once, and then for some reason I can get it to upload. So you get your 4726. Okay, numerical section 2 then. It's the start of our drug calculations. We've got a man that's 100 kilograms and a dose of 15 milligrams per kilogram. So we'll do 100 times 15, which is 1,500 milligrams. One tablet contains 150 milligrams. So I'm going to divide by 150, which is, helps if actually writing the answer, doesn't it? Getting ahead of myself here. 10 tablets in total. He's going to take these for 5 days. So I'm going to do 10 divided by 5, which would be 2 tablets each day. Now, he's going to take these every 6 hours. There are 24 hours in a day, so divide that by 6, and that would be 4 times per day. So we're doing 2 divided by 4. Make sure you divide this the right way. 2 divided by 4 is a half. It's half a tablet each time. Okay, next one. An antibiotic is prescribed as tablets which contain 250 milligrams. A service user is required to take 2 tablets twice a day for 7 days. Okay. Sorry about the noise. I'll just pause it. Okay, so there's 250 milligrams in one tablet. He needs to take 2, oh, that should be a times, 2 twice a day for 7 days. So we'll do times 2 for how much per day. No, times 2 for how much each time, times 2 for twice a day, times 7 for 7 days. In fact, we don't need a calculator for that. 250 times 2 is 500, times 2 is 1,000, times 7 is 7,000 milligrams. We are asked for an answer in grams. There are 1,000 milligrams in a gram, so I need to divide by 1,000 to get 7 grams. Last numerical section then, probably the hardest one, is our weight per volume and drip rate question. So we've got a solution that's at 2% weight per volume concentration. Remember that 2% weight per volume means 2 grams in 100 ml. Okay, the 100 comes from the percentage and it's always grams and millilitres. That's just the standard idea. Okay, so we've got 2 grams in 100 ml. We want 50 grams. We ignore this. This is given over 48 hours. We're not interested in that to part B. Okay, so we want 50 grams. We've got 2 grams in 100 ml. So doing want over got times what it's in. So 50 divided by 2 times 100 is 2,500 millilitres. Okay, let's see if we can change that into a drip rate then. So 2,500 millilitres. Write it down quick before we forget it. It's going to be administered as 20 drops per milliliter. So I need to times that by 20. That gives me 50,000 drops. That's in total. That's over 48 hours, which is where the 48 came in part A. So for 1 hour, I'm going to divide it by 48. This doesn't give you a very nice number. I'm reaching for the wrong calculator again. Where's my calculator? There we go. 50,000 divided by 48 is 1,041.66666, and the 6's are just going to continue. So that's for 1 hour. We're interested in a minute. Sorry about my daughter in the background. So we're going to divide by 60. So 17.36 drops per minute. We are asked to round to the nearest whole number. Nearest whole number after the decimal point's at 3, so that doesn't round that up, so it'd be 17 drops per minute. Okay, I hope that helps. If you haven't already done so, try the second test. See how you get on. You can always rewatch this video with any of the questions that you're getting wrong. If you've still any problems, please get in touch with me. I'll get back to you as soon as I can. Okay.